Okay, so today we are going to discuss problems related to joint distribution, mainly related to discrete one, and in the next class then we will discuss about continuous joint distribution. So the first problem says that you have given p of xy, which is the notation for joint distribution. So if it defines a joint PMF, then find the value of K. So first recall the definition for joint PMF and then under what conditions it becomes a joint PMF. So you can see that this is what we are mainly interested in, summation over all x and all y, P of xy should be equal to 1. So if I put the summation here, I can use any of the order, either I can start with x or y. So if I consider y, then try to see that what are the limits of y and then what are the limits of x, then k plus 1 and n plus 1, this should be equal to 1. Now y is moving from 1 to x and x is moving from 1 to n. The only confusion which may come to your mind is that why not y is moving from 1 to n instead of 1 to x. So actually if you see here, then this x is a variable. Yes, x is less than equal to n. Suppose n is equal to 10 and your x is 6. So in that case it is less than, this is also satisfying the inequality, but it can go till 7 also, 8 also, 9 also and 10 also. So it's a variable. So initially you are fixing this x and then in the next summation you can see that you are moving x from 1 to n. It could be 1, it could be 2, it could be 3 and it can go till n. So this is how the summation works. X you are considering at a time, it is fixed and then it is taking the values 1 to n. So that's why you cannot consider y to be from 1 to n. Y is from 1 to x and x has n values, so that's why there is a summation x from 1 to n. Now if this is clear, then now you can quickly try to compute the value of k. Here k plus 1 and n plus 1 is a constant, then there is a summation y from 1 to x and there is a constant 1 here, this is equal to 1. Now if you see y equal to 1 to x and this summation, then it is actually 1 plus 1 plus 1 and total x terms are there. So if you add 1 x times, it becomes x. So that's why it becomes k plus 1 by n plus 1, then summation x from 1 to n, x equal to 1. Now if you see this summation, then x is variable now. So that's why it is 1 plus 2 plus so on until n. This becomes n plus 1 by 2. So n plus 1 by 2 equal to 1. n plus 1 and n plus 1 cancels out. And that's why you get a quadratic equation k square plus k minus 2 equal to 0. That gives you the value of k equal to minus 2 and 1. If you change the order also, so I am just writing down what would be the summation, rest you can try by yourself. If you consider summation from x, so x is moving from y to n and then y should be moving from 1 to n. In that case also you will get the same answer. So you will get two values for 1 and minus 2. Either you substitute k equal to 1 or minus 2, you will realize that you will getting the same value for pxy. The next part asks for marginal PMF. So this part is done. Then let's move further. So now fxy has already been computed. We need to compute marginal PMF. So recall the definition: marginal probability mass function of x. So it is pxy, but the summation is over y. And if you have to compute PMF for y, then the summation would be over x. So f of xy now is, substitute k equal to 1. So this is 2 by n plus 1. It means if you compute fx, don't get confused in the notations fx or px. Then you have to consider summation over y. And for fy, you have to consider the summation over x. Now the limit of y are very clear. So y is moving from 1 to x. Then 2 by n plus 1. And x is moving from y to n, and 2 by n plus 1. 2 by n plus 1 is a constant. So that's why in both the cases, in the first case, the summation y equal to 1 to x. So there are x terms. So that's why it becomes x. In the second case, x is starting from y going till n. So there are actually, how many terms are there? What you have missed? You have missed y minus 1 terms. So that's why n minus y minus 1 terms have been missed. So this becomes 2 times n minus y plus 1 divided by n plus 1. So these are the marginal PMF for x and y. There is one more part which asks that, is the given distribution or are they independent? So are x and y independent? So they are independent if fxy is equal to fx fy for all x and y. So if you have to prove that x and y are independent, then for all values of x and y, you need to show this relation hold. Otherwise, you need to find a counter example where it does not hold. Yes, in this case, counter example is very easy to find. For example, if you consider fxy and 1, 2. Can you tell me its value? What is the value of fxy 1, 2? Now when you say 1, 2, so x is less than y. So when x is less than y, this value is 0. Now compute fx1 and fy2. Multiply them and you will observe that fxy is not equal to fx fy. That's why x and y are not independent. It has few more parts, this question. No, so question is done. The next question, read it by yourself. Now you have given a table, and from based on the table, certain questions need to be answered. First one says, what is the probability that there is exactly one car and one bus during a cycle? So which means you need to consider P of xy and 1, 1. So this is already the value 1, 1. So that's why 0.030. There is at most one car and at most one bus. Please do try by yourself. So this part is x is less than equal to 1 and y is less than equal to 1. So we need to consider all possible values when x is less than equal to 1 and y is less than equal to 1. So it means P00. So this is your P00 plus P10, so this is P10 plus P01, this is P01, and P11, which is already there. Add them and the answer is 0.120. Yes. Now next parts are a little bit more interesting. Let's see them. So next part says that what is the probability that there is exactly one car during a cycle. So when it says exactly one car, it means they are not talking of buses, they are only talking of cars. So there are two ways of looking at it. Either you look at probability of, this is probability x equal to 1, assuming that y is 0. Yes. So in that case, actually you have to take the marginal distribution. So P of xy when x equal to 1, which becomes summation y, and y is moving from 0 to 2, and P of xy x equal to 1. It means that this would be P10 plus P11 plus P12. So if you fixed x equal to 1 here, then you have to find the sum of these three values. This gives you probability of x equal to 1. Similarly, when exactly one bus is there, you have to add this column. So probability of y equal to 1. So now summation is over x 0 to 5, and x is moving and y is 1. Here x was fixed and y was moving, and that gives you the required answers. The next part says that the left turn lane is having a capacity of 5 cars and one bus is equivalent to 3 cars. What is the probability of an overflow? So what does overflow means? Overflow means that in the lane you have more than 5 cars. So you need to find some probability when there is more than 5 cars. Yes. Now you need to see the different combinations when the capacity is more than 5, where one bus corresponds to 3 cars. So if I write x plus 3y, so x is denoting the number of the cars. For example, x is 2 and y is 1. So total 5 cars are there. So you need to see the all possible combinations when x plus 3y is greater than 5, where y can take the values 0, 1 and 2. For example, if you take y equal to 0, then for none of the combination it does not work. So you have to consider y equal to 1 or 2. When you consider y equal to 1, so already 3 is there. So for x equal to 3, 4, 5, so 3, 1 plus 4, 1 plus 5, 1. In all these combinations it is greater than 5. And similarly, if you see the probability when you take y equal to 2, then in all the cases whatever x is, it is always greater than 5. Or other way around is you can consider it as 1 minus probability x plus 3y less than equal to 5 and see all possible combinations. So again, not a difficult problem. Try to verify the answer by yourself. are x and y independent? So again recall, for the independent, fxy should be equal to fx fy for all x and y. Now if you consider probability of y equal to 0, then you add this column. Y equal to 1, you add this column. Y equal to 2, you add this column. Similarly, this row gives you x equal to 1, then x equal to 2, and so on. So computing marginal PMF are quite easy. Then you have to verify for all the values, and if you verify, you will realize that for all xy, f of xy is same as f of x, f of y, and therefore x and y are independent random variables. Let's discuss the last part. So now toll for car is $3, for bus it's $10. Compute expected revenue from a single trip. So how does the revenue is computed? For example, if 3 cars are there, then revenue would be 9. So you multiply 3 by 3. So it means for the revenue, you are computing the expectation of 3x plus 10y. So this is same as when you have to compute the expectation. So it is 3x plus 10y f of xy when y is moving from 0 to 2 and x is moving from 0 to 5. Now you need to substitute the values because you have all the values, and get the required answer, and then verify with the answer which is there in the slides. Now next question says that there are 2 different professors. X denote the typographical errors by first professor and Y denotes the errors by the second professor. X is Poisson distribution with parameter mu1. Y is Poisson distribution with parameter mu2. X and Y are independent. Now find the joint PMF of X and Y. So joint is fxy, but it is given they are independent. That makes it easy to compute. Otherwise we don't have any idea at this stage how do we compute it. Now x is Poisson with parameter mu1, so e raised to the power minus mu1 raised to the power x by x factorial, e raised to the power minus mu2 raised to the power y by y factorial, where x and y are 0, 1, 2 and so on. Next part says that probability that at most one error is made on both exams combined. These questions are easy. First try them by yourself and then see the answer. So if you combine them, then in total there is only one error, at most one error. There may be possibility there is no error also. So under what values of x and y, this sum x plus y is less than equal to 1. So you need to consider probability 0, 0, probability 0, 1 and probability 1, 0. Now you simply need to substitute the values here. E raised to the power minus mu1 minus mu2 is common. In the first case, when you substitute x and y 0, it becomes 1. When you substitute x1 y 0, it becomes mu1, and similarly when you substitute y1 and x0, it becomes mu2. That gives you the required answer. The next part says that obtain a general expression for the probability that total number of errors in two exams is m. So probability of x plus y equal to m. This is little bit tricky. You have to think a bit. You cannot answer it directly. So at this stage directly we do not see that how do we, because we do not know the distribution of x plus y. We know distribution of x, distribution of y, but this does not mean that we know distribution of x plus y. And this is why we need to consider it separately. For example, if I substitute x equal to k, then y would be m minus k, and we know that x and y are independent, so we are very close. But does it work? Because you are fixing the value of k. So technically k can take any value between 0 and m. If you use this summation, then of course it is absolutely correct, because for example if k is 1, then y is m minus 1, and their sum would become m. So x plus y would become m. So there are several possibilities when x plus y could become m, and that's why you need to consider this summation. Now this is same as probability of x equal to k and probability of y equal to m minus k. Now e raised to the power minus mu1 minus mu2 is common. Then there is a summation. Then mu1 raised to the power k by k factorial, mu2 raised to the power m minus k by m minus 1 factorial. Yes, if you leave the answer here also, this is correct. But if we are looking for general expression, then actually we are looking for PMF for x plus y when x and y are Poisson distribution and they are independent. So for the general expression, what I do, I multiply and divide by m factorial. Then there is k factorial, m minus k factorial, mu1 raised to the power k, mu2 raised to the power m minus k. If you combine m factorial with this one, then this becomes e raised to the power minus mu1 plus mu2, then summation m factorial I am taking out, and then it becomes mck mu1 raised to the power k mu2, and now you must be able to recall that it is binomial expansion. So e raised to the power minus mu1 plus mu2, then mu1 plus mu2 raised to the power m and divided by m factorial. Now this is very beautiful thing, because x plus y becomes Poisson distribution. So x plus y is Poisson distribution with parameter mu1 plus mu2. This is what we are looking for. So this is the last question. Again, spend some time and think over it. So in this question, we need to see that how can we compute probability of x equal to 4 and y equal to 2. Yes, because we do not know the joint distribution for x and y. We only have the PMF for x. Yes. So now if I say that this is equivalent to probability of y equal to 2 given x equal to 4 multiply by probability of x equal to 4. because probability of A given B is probability of A intersection B divided by probability of B, or probability of A intersection B, which is probability of A and B, x equal to A and y equal to B, which is same as probability of A given B and probability of B. Now probability of x equal to 4 is known. Still, how do I compute this one? Now if you see here, then what it says? It says that 4 customers buy cameras, and out of these 4, 2 buys extended warranty. It means it is a binomial distribution when there are 4 trials and 2 successes. So this becomes 4C2. Now what is its probability? It says 60% of customers who buys these cameras buy an extended warranty. So probability is 0.6 raised to the power 2, 0.4 raised to the power 2, and multiply by probability of x equal to 4, which is 0.15. So this gives you the required answer. So that's all from today's class. In the next class, we will discuss questions on continuous joint distributions.